Okay, sorry about that, guys. Like you mentioned, I would, president of Linear AMS, and we have been doing conformal cooling inserts for specifically injection molding industry, roughly since 2005. We did our first major complete tool in 2008. Just real quick, a crash course in the metal additive that we use, and metal additive in general, and why it's important, because you're building things a layer at a time. You can put geometries in parts, as many of you probably already know, that you couldn't conventionally machine in, which is why it fits perfectly into putting water channels and cooling lines in tooling applications. But some of the things, obviously, is you reduce complexity, reduce time to market, and a lot of this stuff is kind of featuring what the technology can do with end-of-use parts as well as, and not just tooling inserts. A lot of the metal, the main metals that are used in the laser powder bed technology, you kind of see on the screen here. What we'll focus on is the maraging steel, the MS1, which is what we use for tooling applications, because of its, again, it's the hardness and strength of it and ductility that remains. You can hard it up to 58 Rockwell. And then getting into the conformal cooling side of things, which is why we're all here. Basically, what is conformal cooling? We're going to go through when it's used, what are the benefits, some design considerations, which is where we get into the simulations and optimizing your design and water channels, where it makes sense, and then go through some case studies. So what is it? It's basically optimization of cooling or heating channels that follow the shape of a part or contour perfectly to the part, so that the part, even though it has complex geometry, it's the benefits of cooling or heating channels that match that geometry, as opposed to a standard conventionally drilled water line, which is obviously always straight, always round, and cannot conform to anything except those constraints I just listed.
This is pretty cool.
The conformal cooling, what it'll bring is, when you have that uniform cooling, obviously the three main benefits are reducing strap, reducing cycle time, increasing existing capacity, but it all is all about uniformly cooling a part. All of those things are benefits of when that happens. So when you have a part that's molded and it's at the end of its cycle, or the end of the injection cycle itself, there's areas on that plastic part, because of inadequate cooling in the tooling, that are hotter than other areas of the part. When you have to wait for those areas to kind of uniformly get to the same temperature, it drops that cycle time. You're waiting to reduce warp, and get a nice part when it ejects off. So it all just ties into being uniform temperature during the manufacturing process. We'll also go through how the actual inserts are built and the process we go through from simulation to design and optimization, the actual sintering process, and a little bit of post-processing.